Have you ever used voice search and gotten something completely wrong? Maybe you asked for the screen painting and got results for screen printing. These little errors, known as cascading errors, have long been the Achilles heel of voice search technology. They happen because, for years, the process was complicated. Traditional voice search had two separate steps. First, it converted your speech to text using automatic speech recognition, or ASR. Then, it ran a standard text search. One mistake in that first step, and the whole search was ruined. But Google has introduced a radical new approach that changes everything. It's called speech-to-retrieval, or S2R, and it completely bypasses the need for text transcription during the search process. This isn't just an improvement, it's an architectural shift, a new direct line from your voice's meaning to the information you need. In this video, we'll break down exactly how S2R works, why it's a game changer, and what it means for the future of how we interact with technology. First, let's start by understanding why that old cascade model was so limiting. Imagine you're in a noisy room. You ask your phone, when is the next train to Austin? The ASR system struggles with the background chatter and mishears train as drain, or Austin as in Jane Austen. The search engine receives the text query, next train to Austin, and gives you irrelevant results. You have to start over. It's frustrating and inefficient. The core issue was that the text was the bottleneck. We think and speak in intent and meaning, but the machine had to convert that into a rigid text format first, losing valuable contextual information along the way. Google's S2R system solves this with a sophisticated machine learning architecture based on dual encoders. It's brilliant in its simplicity. The system has two main parts. An audio encoder listens to your raw speech and converts it into a dense numerical representation called an embedding, or vector. This vector isn't just words, it captures the semantic meaning of your query, including the nuances of your intonation, accent, and the surrounding sound environment. Simultaneously, a document encoder does the same thing for billions of web pages and documents in Google's search index, turning them into their own set of vectors. The magic happens next. The system is trained to place the audio query's vector close to the vectors of its most relevant documents in this massive digital space. When you speak a query, the system finds its location in the vector space and retrieves the nearest documents. No text transcription needed. It's a direct meaning-to-meaning match. This seemingly simple shift has some major implications for the user experience. The first is obvious: accuracy. Remember the screen painting example? S2R focuses on the intent behind the sound waves, so it understands you're asking about art, not home improvement. Errors from misheard words are drastically reduced. The second benefit is speed. By cutting out that entire ASR middle step, S2R processes queries faster, leading to quicker answers and a more seamless experience. The third and perhaps most exciting benefit is a better understanding of natural language. Humans use expressive signals in our speech. S2R learns from these, leading to a more natural, human-like interaction. It also improves multilingual support. The models can handle various accents and dialects more effectively than traditional transcription systems. Google has already started rolling out the S2R engine in its products, and the impact is huge. It's powering a more reliable and enjoyable voice search experience for millions. This technology opens the door for a truly hands-free, seamless interaction with our devices, whether we're driving, cooking, or simply prefer to speak our queries. But where does S2R go from here? The ability to directly map audio intent to data has applications far beyond simple web search. Imagine being able to search through massive archives of audio recordings, podcasts, or even video libraries based purely on what's being said and intended, without a mountain of transcribed text. In healthcare, it could help analyze thousands of hours of patient-doctor conversations to find trends or specific entities, a process that used to be incredibly time-consuming and prone to transcription errors. The potential for applications is vast. S2R represents a fundamental shift in how we bridge the gap between human communication and machine understanding. So, to quickly recap, the old way of voice search was author transcription followed by text search, which had cascading errors. The new S2R method uses dual encoders to directly map audio meaning to document meanings, leading to faster, more accurate, and more natural results. The next time you use voice search and it just gets it right away, you can thank the S2R architecture working behind the scenes. We're curious to know what you think. Will S2R change how you use voice assistants? Let us know in the comments below. If you enjoyed this deep dive into Google's latest AI breakthrough, be sure to like this video and subscribe for more content on the future of technology. Thanks for watching, and we'll see you in the next one.